Introducing OSPF multi-areas, the solution to all of our OSPF problems. Using multi-area OSPF will reduce the size of our linked state database, summarize our routing tables, and it will contain update messages to a single area. The price we pay for all this OSPF goodness? Complexity and a little extra time. Let's take a closer look at how this actually works. But first, let's mix it up a little and use a brand new network diagram. So we're going to split these routers into areas. An area is simply a group of routers. Now it goes without saying, this is a very simple 5-router network, so no need for multi-areas. However, for the sake of simplicity, imagine each area containing multiple routers. Generally speaking, it's recommended to have less than 50 routers in an area, but there's no real hard limit. It all really depends on the processing power of your routers. When it comes to designing your OSPF areas, there's some planning that needs to be done. First of all, you need to start with Area 0. This is known as the backbone area. Every other area must join to the backbone area. Secondly, to benefit from OSPF areas, you need to plan your subnetting. As you can see here, Area 1 has all of the 10.something networks, and Area 2 has all of the 172.16 something networks. This really is the key to successful OSPF areas. Let's take a look at how we can summarize our routes. Router 2 and Router 3 are known as Area Border Routers, or ABRs. These are special routers that have interfaces in 2 or more areas. This gives them the power to summarize routes from each area. For example, Router 2 can take all of the 10.something networks and say, hey, any packets to the 10.0.0.0 network, send them my way. Router 3 also says any traffic for the 172.16.0.0, leave it to me. And they both send a single route to Area 0. Router 2 and Router 3 will also summarize Area 0's subnet to Area 1 and 2. This route summarization instantly wipes out all of our OSPF problems. The routing table is drastically reduced because huge subnet chunks are summarized into a single route. As a result of this, there are far less LSAs flying around, reducing the size of the LSDBs. The updates are usually contained within their own areas as well. For example, Router 1 doesn't care if the 172.16.5.0 link goes down. All it knows is Router 3 has all of the 172.16 subnets. So it just sends it over and lets Router 3 deal with it. This stops the need to run SPF every time a change occurs, unless that change happens within the router's own area. The exception to this would be if the ABR interface went down itself. It would then need to tell the other areas that something terrible has gone wrong. So after some careful planning and a little extra time, we now have a scalable OSPF network using multiple areas. Before finishing, we've already looked at ABRs, but there are some others. Backbone routers. These are all routers that are in, or partially in, the backbone area. So in this case, Router 1, Router 2, and Router 3 are backbone routers. Area border routers. We've already looked at these, and they are routers that connect to more than one area. Router 2 and Router 3 are ABR routers. Internal routers. These are all routers within a single area, but not the backbone area. Router 4 and Router 5 are known as internal routers. Lastly, Autonomous System Boundary Router, ASBR. These are routers that connect to other non-OSPF routing protocols, such as BGP or EIGRP. For example, this may be your edge router connecting to the public internet or another autonomous system network. That's it for multi-area OSPF. With a bit of planning, and some extra time, you really can scale up OSPF far and wide.